Many commands in R accept arguments for color, and you can define the colors in R in many ways. One of these ways is to simply state the name of the color. You can see the name of the available colors in the R colors document that you have received. Another way is to provide the RGB code for the color, and the RGB stands for red, green and blue, and that's a way of defining colors in computers where every color is built up from 3 color channels, the red, green and blue channel, and by mixing these in different ways you can achieve a lot of different colors. Usually the channels ranges from 0 to 255, and therefore you can theoretically mix 256 to the power of 3, that is something like 16 million different colors. And when defining them, you simply write color, or whatever the argument is called, equals, and then within citation marks a number sign followed by the 3 codes for R, G and B. Unfortunately, you can't provide them in the usual form that you would get them, like 139, 28, 98, but you have to provide them in hexadecimal format. Hexadecimal is where you don't only have the digits 0 to 9, but you also have A, B, C, D, E and F. So in this case, the color maroon 4 would have these color codes, and that would translate into 8B1C62 hexadecimal. So it's a bit complicated. Fortunately, there is a command that lets you provide the RGB codes in decimal form instead, and that command is called RGB. So instead of giving the color codes in this way, you can write color equals RGB and then the color codes, and they are not provided here from ranging from 0 to 255, but from 0 to 1. So 0 is in this channel no red color at all, while 1 would mean maximum amount of red, and the same for green and blue. So 0.545 is somewhere in between, and this would also be the color maroon 4. Usually you get the color codes like this, and if you want to enter them that way, you can simply divide everything by 255 and use the RGB command. Yet another way of defining the colors in R is to simply give a number between 1 and 8, and there are 8 predefined colors. These are not the same as those presented in the R colors document. Those are other numbers. But 1 is black, 2 is red, 3 is green, and so forth. And you can even use higher numbers. 9, for example, would be 1 black again. 10 would be red, and so forth. So they just recycle. If you would like to provide the colors as HSV codes, that's hue saturation value, then you may look at the HSV help text to get more instructions. Since this is a Karolinska Institute KI course, I thought it might be a good idea to provide the RGB color codes for the KI profile colors. So these are the codes you might use if you want to align the colors of your R graphs to the colors used in the, for example, PowerPoint templates provided by KI. Another thing you can do with colors in R is to use transparency, because the RGB parameters can be extended with a 4th value, which stands for the opacity of the color. And the opacity ranges from 0, which is maximum transparency. Actually, it's not quite see-through, but you can still see the color very vaguely. up to 1 or FF or 255, depending on how you define it, which is fully opaque, that is the usual color which covers anything beneath it. In this example, we make a plot with 400 normally distributed x values, 400 normally distributed y values, filled points, rather large, 4 times the original size. And the color is this one, the maroon 4 color, extended with a opacity value of 0.2, indicating 20% opacity. And the result looks like this. And as you can see, the transparency makes it easier to tell that there is quite a lot of dots here in the middle compared to the periphery.